Hello everyone and welcome to Linux Forensics here at Pentester Academy. In this video, I wanted to show you how you could use a simple Python script in order to mount an image from a system that is MBR based, master boot record based, without extended partitions. So what I've done is I've created a pretty simple Python script. I import a couple of required items, namely sys, which allows me to get command line arguments, OS path, which allows me to test for files and directory to see if they exist, and subprocess, which allows me to create a new process, essentially to run shell commands from within my Python. Now, for now, I'm going to skip over this class definition and we'll start down here. So here I have a basic usage function. What does it do? It just types out, hey, here's how you use the script. You call it and you give it an image file. And it will attempt to mount partitions from that image file. Here's my main method. Did you give me less than 2 arguments? That means you gave me nothing, because there's always one argument that is the program that you ran. So if you did that, I call usage, which will exit my script. If not, I will check and see if the file that you specified on the command line exists, and it's really a file. So that's sysargv1. Sysargv0, again, is the program that you're running. If it doesn't exist, I will complain to you, and I will say, print out this message, file sysargv1 can't be opened, and I exit. By the way, of course, you're going to run this script as root because you can't mount anything if you're not root. I didn't put a check in here to see if you're root. I suppose I could have. Here, I open the file, and this is a somewhat recent construct from Python, and it's preferred to other methods where you might open and check for an error, or you might put stuff in a try-catch block. If this looks new to you, it's because this is somewhat new to Python. I want to say Python version 2.5 and newer have this ability. And it's called with open. So I open my file as read-only in binary mode, which, by the way, in Linux is not really required, but this is good for compatibility with Windows. So what I'm doing is I'm opening my file, and I'm going to call that file object F, and I'm going to get the first sector. So the first sector I'm going to convert to a string, and I'm going to call read on F, and I'm going to say, please give me 512 bytes. Then I check, and I say that sector are the last 2 bytes 55 AA. If they are, that tells me this is either a master boot record or something called a volume boot record, which is a Windows fat file system thing. We won't talk too much about fat file systems in this course. We might in a future course, say on Windows Forensics. If this is an MBR, then these bytes for the 4 partition entries should either be 80 or 00. So I do a little check, and I say, are all of these either 80 or 00? If they are, then it must be an MBR. Now, if you look down here a little bit, you'll see else it must be a VBR. And I will go ahead and try to mount it. So this script isn't necessarily specific to just Linux partitions. So back to this section. I create a list, and I call MBR record, which is the class I defined earlier, so we'll get back to that in a bit. And I pass it my sector, and I give it an index. And this will generate up to 4 partition entries called parts. So now I have a for loop, and I say for p in parts, print it out, print out the information, and if this partition is not empty, then I will try to mount it, assuming the partition type is not 238 or 5. And I should probably update this with some additional partition types as well, because there are other extended partition types. By the way, 238 is a partition type for something called a globally unique identifier partition table. And if it's one of these, I say, sorry, I don't support that in the script. Otherwise, I try to mount it. So I say, what's my mount path going to be? Where am I going to put it? Well, I'm going to put it under media part %s, and I'm going to substitute for %s the part number as a string. And if that directory does not exist, I will create it. I will call subprocess call make directory for that mount path. My options for mounting will be loop. It's a file, not an actual device. Read only. Please don't update the access times. I will set my offset equal to something I'm going to calculate, and I'm going to calculate it as the start. And again, recall from the previous video that start means the starting sector, and the sectors are normally 512 bytes long. That's my offset, and I call mount. And that's it. And here I have a little trick that some of you might be familiar with. I say if _name _equals, and then in quotes _main _, then please run main. All right, so let's go back to our class. So here's my class. Every Python class should have a constructor defined, and here I do. I've defined my constructor, which is called $_init, and every class method in Python starts with a parameter of self. Parameters that are passed in are sector, which is my 512 bytes for the sector, and partition number, starting with 0. I then set the partition number equal to what was passed in, and I calculate my offset into the 512 bytes as 446 plus the partition number times 16. Recall there are 16 bytes per entry. I say this is not active, and then I check, and I say is the very first byte 80, then I set active to true. Now I will look at the type, and I will say the type is equal to the ordinal value. This is an easy way of saying what is the value stored in this byte. And it's stored in the 4th byte, actually the 5th byte, but it's offset 4. That is partition type. And I say it's not empty. But if the type was 0, that means that it is in fact empty. If it's not empty, or even if it is, it doesn't hurt to make this calculation. I say what is the starting sector? How many sectors before it? And it's stored in little endian format, so it's just the first byte plus 256 times the next byte plus 256 times 256, also known as 65,536, times the next byte, and then 256 times that, or this value, 16,777,216 times the last byte. The same thing is true for the total sectors. So it's the exact same calculation. I define this method called printPart, and it has only one parameter, self. And if it's empty, I just print empty. Otherwise, I print out, if it's active, I print out bootable. And either way, I print out the type, the start, and the total sectors. We'll go ahead and run this script real quick. So I'm going to type mount image pi, and I'm going to pass it media, fill, Toshiba, disk images, df2, 17dd. And there you have it. It says it looks like an MBR. It has one bootable partition, which is type 11, which is a FAT32 partition, starting at sector 63, and this is how many total sectors it had. The other 3 entries were empty, and if I do a quick mount command, I should see here at the bottom, in fact, I have mounted this file on media part 0, and it's a VFAT. So if I do an ls on media part 0, there it is. Exactly the same as in the previous video. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.